Hello everyone. Uh, Welcome to second lecture of embedded system course. So in last lecture we started with chapter number 1, that is 8051 programming in C, and actually we took overview of the chapter, uh, that is about contents of the chapter, and then we discussed about uh, introduction to embedded system. Now in this lecture we are going to focus on first point in this chapter, that is overview of 8051 architecture. So you have already taken course on 8051 microcontroller, in which you have studied in very details architecture of 8051, its instruction set, and its programming in assembly programming language. Now let us take a very brief overview of 8051 microcontroller. So in this we are going to discuss these points. First we will see 8051 important features, then we will see 8051 architecture diagram, then we will compare few microcontrollers from 8051 family of microcontrollers. Then we will discuss about uh, internal registers of 8051. Then we will see about RAM of 8051 and how that RAM is allocated. That we will see, and in the last we will take questions. So the first point, 8051 important features. So all of you know that in year 1981 Intel introduced 8051 microcontroller, which is generally referred as MCS51. Features of 8051 microcontroller are we are you are very well known, aware with that 8051 microcontroller is 8-bit microcontroller. It contains 128 bytes of RAM, 4 kilobytes of ROM. It is having two timers, timer 0 and timer 1, one serial port for serial transmission and reception, and four IO ports, that is 4 by 8. That means four IO ports are having 8 lines each. So in this way, total number of IO lines in case of 8051 microcontroller are 32. So these IO ports can be used to interface external peripherals with 8051. 8051 microcontroller is having 6 interrupt sources, like external interrupts, INT0, INT1, timer interrupt, then serial port interrupts, etc. So 8051 microcontroller becomes very popular after Intel Corporation allows other manufacturers, that is the manufacturer of other microcontrollers, to make and market any flavor of 8051 but with code compatibility. The meaning of this statement is that Intel opened its 8051 microcontrollers architecture, internal architecture, to other manufacturers, so that other manufacturers can manufacture uh, microcontrollers based on this architecture, which will come under 8051 family of microcontrollers, but with one condition, that it should have code compatibility. Means the program written on these microcontrollers manufactured by other manufacturers, uh, it should run as it is on Intel's 8051 original 8051 microcontroller. Some of the manufacturers which are manufacturing 8051 family of microcontrollers are Intel, Atmel, Philips, Signetics, AMD, Infineon, Dallas Semiconductor, that is Maxim. These are the manufacturers which are manufacturing 8051 microcontrollers. Okay. Uh, Next point is 8051 architecture diagram. So here I have displayed uh, general architecture diagram of um, 8051 microcontroller. So at the heart of this architecture of 8051 microcontroller, there is a CPU, that is central processing unit of this microcontroller, which is 8-bit CPU, central processing unit. Means the arithmetic and logical unit inside this CPU is capable of doing arithmetic and logical operations on 8 bits of data. That is the meaning. So this CPU is connected with all other peripherals. So remaining blocks are actually control units and peripherals. So this CPU is connected with all these peripherals and control units with internal system bus. Okay. So see other blocks. So this is on-chip ROM, that is read-only memory, available in 8051, that is connected with CPU in only one direction, that is from this on-chip ROM towards CPU. Means data bytes can be read in by this CPU from this on-chip code ROM. Next is on-chip RAM. So CPU can write or read from this on-chip RAM, that is temporary storage memory. Means CPU can write in or it can read from. So here bus is shown bidirectional. Then timer 0 and timer 1 are interfaced with CPU. Then serial port, then IO ports, 32 IO port lines. Then bus control unit. So whatever traffic of data on the system bus, internal system bus, that is under the control of this bus control unit. Then interrupt control unit. So these two lines shows external hardware interrupts and other interrupts are internal, that is timer 0, timer 1, serial port interrupt, etc. CPU is powered with oscillator normally of 11.0592 megahertz. So this is about architecture of 8051. Next point is comparison among 8051 family of microcontrollers. So we cannot compare all the microcontrollers from the family of 8051 microcontrollers. So for example, we have taken only 3 microcontrollers for comparison. So 8051 original microcontroller, then its enhanced version, that is 8052, and another microcontroller 8031. Now this comparison is based on few features. First feature is ROM, available ROM, RAM, available RAM, timers, number of IO pins available, number of IO ports available, and number of interrupt sources available. Now in case of 8051, on-chip program or code memory is of 4 kilobytes. In case of 8052, it is double, that is 8 kilobytes. And in case of 8031, there is no on-chip code ROM. Okay, so in case of 8031 microcontroller, if you want to use this microcontroller in your embedded system, then you have to interface uh, external read-only memory or program memory with 8031 microcontroller. Okay, that is the meaning. RAM, in case of 8051, 128 bytes of RAM is available. In case of 8052, double, that is 256 bytes of RAM is available. And in case of 8031, 128 bytes of RAM is available. Timers, number of timers available in case of 8051, 2 timers are there, timer 0, timer 1. In case of 8052, 3 timers are there, timer 0, timer 1 and timer 2. In case of 8031, again 2 timers are available, timer 0, timer 1. Number of IO pins available uh, uh, for this 8051, 8052 and 8031 are same, that is 32 lines are available for IO. Then a serial port, number of serial ports available, same, only one port is available in all these microcontrollers. Number of interrupt sources available, in case of 8051, 6 interrupt sources are there. In case of 8052, 8 interrupt sources are there. And in case of 8031, 6 interrupt sources are available. Okay. Now, under 8051 family of microcontrollers, many hundreds of microcontrollers are there, and depending on your applications requirement, you can select any one of these. Okay, applications requirements means in terms of this feature, how much ROM, how much RAM, how many timers, how many IO pins, whether serial port is required or not, how many interrupt sources are required. According to that, you can select a particular microcontroller from 8051 family of microcontrollers. So next point is about internal registers of 8051. So while programming, uh, you have to use internal registers of 8051. In case of 8051, there are internal register listed here. A is accumulator, which is a very common internal register that you use in many of 8051 instructions. Then register B, then register R0, R1, R2, R3, so on up to R7. So R0 to R7 general purpose registers are there, 8 registers. And B register is special purpose. It is actually implicitly used in some instructions like arithmetic instructions. Okay. And accumulator is normally one of the operands in many arithmetic and logical instructions. Next, internal register of 8051 is DPTR, that is data pointer register. So it is actually 16-bit, means all above register A, B, R0 to R7. These registers are 8-bit, 1-byte registers. But DPTR is 2-byte register. Lower byte is called as DPL and upper byte is called as DPH. Okay, so DPTR register is used to access external ROM memory that is interfaced with 8051 microcontroller. And you have studied in 8051 microcontroller course, you have studied how to use this DPTR. Then program counter. Program counter is again 16-bit internal register of 8051. So this program counter register actually holds the address of next instruction to be fetched and executed by internal CPU of 8051 microcontroller. Okay, so this is about internal registers of 8051 microcontroller. Next point is about internal RAM of 8051. So as I told you, in generic 8051 microcontroller, there is 128 bytes of RAM, and since 128 bytes of RAM, its address ranges from in hex 00 to 7F. Means 00 is first memory location address of 128 bytes of RAM, and 7F is the last memory location address of this 128 bytes of internal RAM of 8051. Out of this 128 bytes of RAM, total 32 bytes in the range of 00 to 1F are set aside for 4 register banks: RB0, RB1, RB2 and RB3. So RB0 is the register bank number 0, which contains 8 bytes. RB1 contains 8 bytes. RB2 contains 8 bytes, and RB3 contains 8 bytes. So in this way, first 32 bytes ranging from addresses 00 to 1F are allocated to these 4 register banks. Out of this, your program can use only one at a time. So after that, total 16 bytes, next 16 bytes in the range of 20 to 2F are set aside for bit addressable read-write memory. Means out of these 16 bytes, from a particular byte from program, you can access a particular bit. So it is called as bit addressable memory. Okay, you can read that particular bit, or you can modify that particular bit. Okay, after that, total of remaining 80 bytes in the range, in the address range of 30 to 7F are set aside for read and write storage, and it is called as scratchpad memory. Means user can use it for any purpose, for temporary storage. Register bank RB0 or R0 is default register bank. We can switch to other banks by using one of the special function register SFR, that is PSW SFR. Okay, section of this RAM can also be used as stack. Okay, so last point is RAM allocation in 8051. So this is the pictorial or diagrammatic view of how this 128 bytes of RAM in 8051 microcontroller is allocated for different purposes. Okay, so we start from 00 address and we can go up to 7F. So this much memory ranges, okay, from address 00 to 7F, that is of 128 bytes. So as I told you, first 32 bytes of this RAM starting from address 00 to 1F, okay, which covers register bank 0 to register bank 3, these 4 register banks. Okay, and stack pointer register, okay, as I told you, out of this memory, that is RAM, we can also use it for stack, and we can start using that stack memory, okay, starting from address 08, okay, that is from register bank 1. Next part is bit addressable RAM, which ranges from 20 to 2F, that is next 16 bytes. Next 16 bytes are bit addressable RAM. Means from this part of RAM, you can particularly read any bit or modify any bit from out of these 16 bytes ranging from address 20 to 2F. And last section is of 80 bytes ranges, that is address ranges from 30 to 7F, and these 80 bytes you can use as scratchpad RAM, that is for temporary storage. Okay, so this is RAM allocation in 8051. Okay, so this is about 8051 architecture introduction in a brief that you have already studied in 8051 microcontroller course. Okay, thank you very much.